Hello, everyone. I'm Ruijie Zhao from Shanghai Jiao University. I will introduce to you our latest research, GeeSolver, a generic, efficient, and effortless solver with self-supervised learning for breaking test captures. Our presentation will include 4 parts: background, the proposed method, experimental results, and conclusion. First, I will introduce the research background. Captcha has evolved as a powerful technology for distinguishing computer programs from humans. Although numerous native to text-based captchas have been proposed, text-based captcha remains the extensive used security solution by many websites and the web service of IoT device. Thus, exciting text-based captcha schemes should be thoroughly evaluated for their ability to withstand various attacks.
Ruijie, sorry to interrupt. Your slides is not navigating. You're still on the first page. Is that expected?
Yeah.
Oh, sorry. Sorry to interrupt.
Oh, okay, thank you. Many strategies for bypassing text-based captchas have been proposed during the previous decades. One earlier approach proposed is to break text-based captchas using segmentation-based approaches. However, when segmentation-resistant measures are introduced to text-based captchas, segmentation-based results become obsolete. Besides, some DL-based approaches have shown outstanding results, but they require a large number of labeled samples for training. The label-intensive and time-consuming label process severely limits the viability of such approaches. Some work noticed this challenge and sought to develop effortless solvers that only require limited label data. However, their solutions are not efficient and generic enough, as they design complex and time-consuming pre-processing procedures to imitate noisy backgrounds, and failed to recognize the captcha with the latest complete features, such as Google Captchas. As can be observed, in recent years, the development of more complex security features is on the rise. A solution that is not generic can be easily outdated and defined. Given the difficult state above, proposing an effective DL-based solver to break various captchas is necessary. It can be concluded that the current mainstream solutions all suffer from one or more following problems. First, previous solvers have achieved significant attack success rates for simple captcha schemes, but they still unable to break captcha schemes with complete security features. Second, while mainstream DL-based solver outperform, they require a significant number of labeled captchas for training. It requires a significant amount of time and effort to label captchas anew if the captcha style changes or new security features are implemented. Third, over-reliance on high complex pre-processing and segmentation technologies makes the recognition process complex and inefficient. In light of the challenges listed above, GeeSolver hopes to achieve the following goals. Firstly, the solver should adopt a generic method to recognize various captcha schemes with diverse security features. Secondly, the entire assault procedure must be as quick as feasible. Thirdly, we need to propose a method to train our solver with a few labeled captchas. Our insight is that numerous difficult-to-attack captcha schemes greatly damage the stand front of characters where security features. And even for humans, the relevant characteristics can only be inferred from local representative information. As a result, this local representative information should be regarded as a key to accurately inferring the capture. The previous solutions mostly rely on obtaining a cleaner or simple capture image, which reduces the difficulty for the solver to recognize. The performance of this solver decreases significantly as the capture security features more complicated. We act in an opposite way to train the latent feature extractor of our solver. And it's extremely difficult to recognize capture with high masking rate is used as the input during training, so that the latent representation extractor learns the latent representation only from local information to reconstruct the target capture. Next, I will introduce our method. In our work, we first develop an efficient solver for breaking test captures, which consists of a VIT encoder and a capture decoder. The VIT encoder, composed of a series of transformer blocks, can extract the latent representation of image patches. Thus, it is also donated as a latent representation extractor. Our encoder first divides a capture image into non-overlapping patches of 7 rows and 20 columns. Then VIT encoder embeds this flattened 114 patches by a linear projection with added positional embeddings. In stage 1, some patches are randomly masked according to the masking rate, and the VIT encoder extracts representation vectors of only visible patches. In the second stage, all patches are visible. According to the common characteristics of capture images, we design the capture decoder composed of an information compression module, a sequencing modeling module, and a decoupled attention module to effectively decode capture sequences from learned latent representation. We apply for the first time MAE style self-supervised learning to build a latent representation extractor for capture recognition. For reconstructing original capture from little visible area, the latent representation extractor learns to extract latent representation from local information that can infer the whole character. Before training the capture decoder, we leverage the standard projection method to enlarge the text area for all labeled and unlabeled symbols. The process of standard projection method is illustrated in the left figure. To take full advantage of unlabeled data, we use a fixed match, a state-of-the-art self-supervised framework to train the capture decoder with a few labeled symbols and the same unlabeled symbols used in the stage 1. Next, I will introduce the experimental results. To evaluate the effectiveness and generality of solvers, we collect 8 capture schemes from the top 15 most popular websites using different security features. Experimental results show that our solver can achieve excellent recognition performance with limited labeled captures. Furthermore, GeeSolver also has a high attack success rate on the previous captures dataset, indicating that our solver outperforms the state-of-the-art method by a large margin. To prove that VIT encoder has learned to extract useful representation that can infer the whole character, we exhibit the reconstruction performance of MAE. As shown in the left figure, all examples are selected from the test set and they are not used in MAE training. The results show that even in the case of a high masking rate, MAE can still reconstruct high quality and correct capture images from a few visible patches. We also list the statistics on the error prediction symbols about the editor distance and the error category. As shown in the right table, it was noting that the editor distance between incorrect prediction and ground truth is 1 in most instances, which indicates that the incorrect prediction are very close to the correct answers. The unpredictable backgrounds is rarely considered in the exciting captcha design. The core of GeeSolver is MAE, which trains the VIT encoder through this construct task of inferring entire characters from their parts. After introducing unpredictable backgrounds, MAE will pay much attention to recovering meaningless and complex backgrounds, which has a huge negative impact on the training of VIT encoder. As shown in the left figure, in case of the same mask, MAE cannot fully recover the captured characters due to the influence of complex background noise, which indicates that adding unpredictable backgrounds can prevent MAE from extracting high-quality representations. We also observe that from the right table that using the unpredictable background reduces the recognition accuracy even more significantly than using all other security features at the same time, indicating that unpredictable background is more effective against the GeeSolver. In this paper, we propose a generic, efficient, and effortless solver for breaking text-based captchas. Our solver achieves a breakthrough in breaking captchas with complete security features. By applying MAE-style self-supervised learning in captcha recognition for the first time, we build a latent representation extractor that can extract latent representation from local information. Our solver requires significantly fewer label captchas and can recognize various captcha schemes with distant security features. So its usability will not be affected by newly introduced security features. That's all. Thank you for listening.
All right, thank you, Ruijie. Any questions?
Hello, thank you for your talk. So I'm wondering, how popular are these sort of text entering schemes anymore? Because in the last few years, I've seen that most of these human AI bot verification has moved to more complex tasks like figuring out bridges or crosswalks or solving challenging tasks. So how popular are these text entering schemes for verification anymore?
Sorry, I didn't hear it clearly.
Maybe you can help to repeat the question. So the question is how popular those text-based captcha system is right now compared to some of the more recent complex captcha system.
Okay, we also do a research about this question. About 15% of most popular websites are still use text-based captchas because they are very user-friendly. Maybe some captcha systems has been proposed with more complex security features, such as image-based captures, but text-based captures still widely used.
All right. Thank you, Ruijie. Thanks the speaker again. Let's